Hardcore parkour.
Yeah!
Did it.
That.
Whoa, what's this? What is that?
I think it's dinosaur remains.
Dinosaur remains? Oh my gosh.
You know what we could do with this?
What?
We can make a dinosaur.
A dinosaur? How?
Notes out of my back pocket.
Ooh.
Will you see, Will? Dinosaurs. The element carbon-14 turns into nitrogen as time passes. When organisms die, ratio between nitrogen and carbon changes. Archaeologists determine how long ago they died using the ratio.
Well, how does that work?
Well, Will, I have created a device that attracts carbon-14 into the deceased bones of the dinosaurs. Now just think about it. What if we take the carbon-14, we insert it in specific areas where the marrow once was in the bones, and theoretically, we could make dinosaurs out of the fossils. In a sense, reverse engineering the dinosaurs.
Sweet!
Get back. I'm about to engage the device. Get down!
You can't kill the metal.
What have I done?
Tastes like. Smells like. Stephen Bartholomew. I'm gonna parkour to find Stephen Bartholomew. Are you Stephen Bartholomew? Can you create a device to destroy the dinosaur?
Go.
You're gonna create the device. You're a joke.
I'm gonna use isotopes.
What are isotopes?
Well, you see, isotopes are varieties of atoms of a chemical element with different numbers of neutrons.
Yeah, that sounds good. What else are you gonna do?
Well, I'm gonna do radioisotopes too, which are chemical elements that has an unstable nucleus and emits radiation during its decay. You think I'm joking? I'm not. It's decay
You're a joke.
in an unstable form. Stability of an atom, nucleus, a number of protons and neutrons, number of electrons, and a valence shell. Think I'm not making sense? It's just because you're not smart enough.
Not really.
You see, radioisotopes are used for dating. It's a technique for measuring the age of the object by determining the ratio of concentration of radioisotopes to the stable isotope in it. Get it yet? No, I didn't think so, because you're not smart enough. How can a half-life determine the age of material? Greater than half-life, longer back. You can date objects? I don't know. Let's just read some more. You see,
sounding stupid right now.
radiocarbon dating, of course, using half-life to calculate the amount of time elapsed since the isotope existed. Alpha radon-222 decays by alpha emission into plutonium
Who are you talking to? The wall and me? Damn it.
218, 8, 6 subscript 222.
What are those numbers
arrow
mean?
2. I don't even know, but I'm going to the next page. Organic contains carbon. Inorganic, more mineral than biological. Uranium, lead are conducted on older inorganic objects because it has a longer half-life than other isotopes. Radiocarbon-14, which is what this is made out of, used on organic material because organisms, not
I think you mean
organisms. Organisms only replenish carbon-14 when they are alive.
What about when they're dead?
Used to find out how long since they died. Well, that's not it.
No, what else you got? How are you gonna
I
create
got-
this device?
I got a whole other page. Beta decay, haven't talked about that, emits a high energy electron by a neutron and changes into a proton during radioactive decay. Atomic number decreases by 1. However, cobalt 60, nickel 60 plus beta particle and gamma radiation has excess neutrons and releases gamma radiation from the nucleus, half-life of about 5.3 years. Using radiometric dating, measurements of lead and uranium. You know, I don't even have to read all this. I'm just doing because
I just
I
don't know
actually
how
all
you're gonna
this
make the
information.
device to save us.
Rich minerals showed that some of the excess of a billion years or so old crystals of zircon form, Western Australia. Don't know why Australia's in here. Maybe I'm wrong. You have bad handwriting. I mean, I wrote this. 4.4 billion years.
And now it's time to go to home.